How's it, grade 11s? So today we're going on to implicit differentiation. I'm working from this chapter in your books, chapter 26. Okay, so far what we've been doing is we have been differentiating functions explicitly. So what does that actually mean? So if you've got a function like this, f of x is equal to 2x squared plus 6x plus 7. Okay, we can see that we have this in terms of one variable. We've got it only in terms of x. So what we can do is we can differentiate this explicitly. Okay, another example would be something like this. Y is equal to a half 4x plus 3 squared. Again, we've got whatever's on the right hand side here in terms of one variable, and we can get it in terms of the one variable. It'll be pretty easy. So this is explicit differentiation, and you would just apply your normal rules. So for here you just differentiate normally. Here you would have to use the chain rule and then differentiate the inside and so on. Okay, what happens if they give you a function like this, for example? If we get xy plus 2y is equal to 3. Now, again, we've got this thing in terms of two variables. We don't just have an x on the one side or another variable. What I can do, however, is I can get that one variable on its own. So we can take here a common y out, and we get x plus 2 equals to 3. Then I can divide through by this bracket, and I get y is equal to 3 over x plus 2. Now what we can do is we can use our differentiation rules, which would be the quotient rule, and we've got this one variable on its own. So it would be explicit differentiation. But sometimes it's a little bit difficult to get this one variable on its own. So for example, if we have something like this, x squared plus y squared equals 25, okay? So yes, I know you can see that it won't be too difficult to get the y on its own, but with higher order cases, it could be a little bit more difficult, okay? Especially when there's a whole heap of other y's in there and things like that. So what we would do here is we would use implicit differentiation. And what I'm going to do is I'm just going to show you if we had to get the y on its own. And I'm just going to do it on the side here. X squared plus y squared equals 25. Take the x squared to the other side, and we get y squared is equal to 25 minus x squared. Take the square root. But remember, if we take the square root, it's always plus or minus. So yes, we can get the y on its own. But now you see we've got two different solutions here. We've got the positive root and the negative square root. Okay, so we'd have to differentiate two different times. So what I'm going to do here is I'm going to use implicit differentiation. And we always differentiate with respect to x. Okay, so if I had to differentiate this with respect to x, the x squared, we would get 2x, just like normal. Okay, plus. Now, here comes this y. Now, just remember that y is a function of x. Just like I've shown you here with these examples here. So f of x is the same as y. So y is equal to something with x's. It's a function of x. Again here, y is equal to something with x's. Here we got the y on its own, and it's a function of x. It's got x's on that side. And that's exactly what this y is. And you can see it over here, that y is equal to something with x's. Okay? So if I put in here what this y actually is, so it's plus or minus the square root of 25 minus x squared. Okay, that's what this y is. Now just remember that that is squared. Okay, so how would we differentiate this red bit? Well, it would be chain rule. So we need to differentiate the outside first. So that would give us 2 bracket, and then we leave the inside. But now I'm not going to differentiate the red one as is. I'm going to differentiate this one. So we've differentiated the outside, which gives us the 2, and it's just going to be y to the power of 1 okay, because we decreased the power by 1. Okay, so that was that bit. So we would get 2, that bracket, which is the y. Then what do we need to do? We need to now differentiate the inside using chain rule. So we would differentiate the inside, but I'm not going to differentiate the red one as is. I'm going to differentiate the y. Okay, now just remember the y is that red thing. But let's just pretend that we don't know what y is, especially with the higher order ones. So what would we say? We would say times, because that's the chain rule, and we times it by the derivative of the inside. And the derivative of the inside here would be dy dx for whatever y is. Okay, in this case, you can see you would differentiate that. And here we would get equals to 0. And then what I can do, grade 11s, is we get this dy dx on its own. So we're going to get 2y times dy dx is equal to minus 2x. Then I divide through by the 2y, and I get dy dx is equal to minus 2x over 2y. We can simplify that, and we get dy dx is equal to minus x over y. Okay, and what we've done there is we differentiated it implicitly. Okay, so whenever we get a y, you just differentiate the outside, then you differentiate the inside. That is the chain rule because of this. Okay, so once again, differentiate the outside, then when you differentiate the inside, you just say dy dx. All right, and that's basically implicit differentiation. So if we go through a couple of examples here. Okay, so we've got example 1a. The question is, use implicit differentiation to find dy dx in the following equations. So we've got, okay, so we've done question A. I will go on to question B. Okay, so question A was that previous one. So we've got x, y cubed plus x squared, y squared plus 3x squared equals to 7. Okay. So if we look at this first term here, we've got x times y cubed. So basically we've got a function times a function. So we're going to use the product rule for that. And you remember the product rule is differentiate the first, leave the second, plus leave the first, differentiate the second. So if I differentiate the first, we get 1 multiplied by y cubed, plus leave the first, differentiate the second. So we're going to have to use chain rule here. So if I differentiate the outside, I get 3y squared. But we now need to differentiate the inside, because remember y is a function of x. So times dy dx, and there's the derivative of the inside. Then plus, again, product rule, differentiate the first, leave the second, plus leave the first, differentiate the second. So if we differentiate the first, we get 2x, leave the second, y squared, plus leave the first, differentiate the second. So multiply the exponent with the coefficient, so we get 2y, decrease the power by 1, so we just get 1, and then we have to differentiate the inside, so we get times by dy dx. Okay, plus differentiate this normally, so we get 6x, and that's equal to 0. All right. So what I'm going to do now, grade 11s, is I'm going to throw everything that isn't a dy dx onto the right-hand side and leave the dy dx's on the left-hand side. So over here, we're going to get 3xy squared times by dy dx. That's going to go to the other side. This one here would be plus 2x squared y dy dx is equal to, I'm going to take this to the other side, so we get minus y cubed. Take that to the other side, and we get minus 2xy squared. Take that to the other side, and we get minus 6x. Okay, over here, I can take out a common factor of dy dx. And I'm left with 3xy squared plus 2x squared y is equal to minus y cubed minus 2xy squared minus 6. Divide through by this bracket and we get dy dx is equal to minus y cubed minus 2xy squared minus 6x all over 3xy squared plus 2x squared y. And that's our final solution. All right, if we go on to question C, we've got x minus y squared equals x plus y minus 1. All right, grade 11. So what I'm going to do here is I'm just going to FOIL this out. Okay, just remember the squared means we've got two brackets. So I'm going to do that in one step. That gives us x squared minus 2xy plus y squared is equal to x plus y minus 1. Okay, now I'm ready to differentiate. Differentiate that as normal, so we get 2x. Product rule, so we get minus 2y, because I just differentiate the first one. And what I'm going to do is I'm just going to take that minus 2 out as a common factor for now. Okay, plus leave the first, differentiate the second. So if we differentiate this, we've got a 1 up at the top. 1 times 1 is 1. Decrease that by 1, we get 0. So y to the 0 is 1. Yes, it's 1. But then we need to differentiate the inside. So it's dy dx. Okay. Then differentiate this one. So it's 2y times dy dx equals 1 plus dy dx. And then that's just 0. Okay. Let's distribute this minus 2 in. And we get minus 2y minus 2x dy dx plus 2y dy dx equals 1 plus dy dx. Dy dx is to this side, everything else to that side. So we get minus 2x dy dx plus 2y dy dx minus dy dx is equal to 1 minus 2x plus 2y. Take out a common factor of dy dx. Equals 1 minus 2x plus 2y. Divide through by this bracket. All over minus 2x plus 2y minus 1. Okay, and there's your solution. Okay, going on to question D. We've got y squared plus x cubed minus y cubed plus 6 equals 3y. Okay. So let's differentiate this, and we get 2y times dy dx plus 3x squared minus 3y squared times dy dx plus 0 is equal to 3 dy dx. Okay, dy dx is to this side, everything else to that side. And we get 2y times dy dx minus 3y squared dy dx minus 3 dy dx is equal to minus 3x squared. Take out the common factor and we are left with 2y minus 3y squared minus 3 is equal to minus 3x squared. Divide through by the bracket, then dy dx is equal to minus 3x squared all over 2y minus 3y squared minus 3. Okay, we're going on to question E. Okay, so we've got y is equal to x squared y cubed plus x cubed y squared. Okay, so here we just got the implicit, so it's dy dx equals product rule, so differentiate the first and so on. So we get 2x times by y cubed plus x squared multiplied by 3y squared dy dx. And then here we can, sorry, there's no plus here. That's just a times. Okay, so here I'm going to differentiate the first times by y squared plus, leave the first, differentiate the second. So that's 2y dy dx. Okay, let's take dy dx to this side, everything else to that side. Guys, I'm also going to simplify things as I do that, so I'm just going to miss a few steps. So we have here dy dx. If I take this to this side, it becomes minus 3x squared y squared dy dx. And then take this to the other side, and we get minus x cubed, sorry, minus 2x cubed y dy dx. And I think that's all of them. And that's all of them, okay? Equals 2x y cubed. And then we've got here 3 plus 3x squared y squared. Okay, take out the common factor, dy dx. And we're left with 1 minus 3x squared y squared minus 2x cubed y equals 2xy cubed plus 3x squared y squared. Dy dx is equal to 2xy cubed plus 3x squared y squared all over 1 minus 3x squared y squared minus 2x cubed y. Okay, so not too bad, guys. Right, last two examples. Okay, so example F, we've got y over x cubed plus x over y cubed equals x squared y to the 4. All right, grade 11. So with this one, I'm going to make my life a little bit easier. I'm not going to use the quotient rule because that one's a little bit intense. So what I'm going to do actually is I'm just going to do this, y times x to the minus 3. It's so much easier using the product rule than the quotient rule, okay? So this one would be x, y to the minus 3 equals x squared y to the 4. Right, now I can just use the product rule right throughout. So this first one, differentiate the first, we get dy dx multiplied by x to the minus 3, then plus y, differentiate the second, minus 3x to the minus 4. Then we just get 1 times by y to the minus 3 plus x. This one here we're going to get minus 3y to the minus 4 dy dx. Sorry, I just had to squeeze it in on the end there. Okay, so what have I done here? I've done that one and I've done that one. So I just have to do it on the other side now. So we get 2x y to the 4 plus x squared 4y cubed dy dx. Right, dy dx is to this side, everything else to the other side, and I'm going to simplify at the same time. So this one will become x to the minus 3 dy dx. That can all go to the other side. Here we've got minus 3x y to the minus 4 dy dx. And this guy can come to the side as well. Minus 4x squared y cubed dy dx is equal to. Okay, so this can stay on this side and we get 2xy to the 4. That can go to the other side, so it becomes minus plus 3x to the minus 4y minus y to the minus 3. And that's everything. Okay, let's take out the common factor. And we're left with dy dx. X to the minus 3 minus 3xy to the minus 4 minus 4x squared y cubed is equal to 2xy to the 4 plus 3x to the minus 4y minus y to the minus 3. Okay, divide 3 by this and we get dy dx is equal to 2xy to the 4 plus 3x to the minus 4y minus y to the minus 3 all over x to the minus 3 minus 3x y to the minus 4 minus 4x squared y cubed. Right, so in terms of simplifying grade 11s, you don't have to, but what I do want you to do is to write things with positive exponents. So that is what I'm going to do now. This one is fine, so we get 2xy to the 4 plus this is going to become 3y over x to the 4 minus 1 over y cubed 1 over x cubed minus 3x over y4 minus 4x squared y cubed. And that's fine. Okay, we don't have to simplify it any further than that, just as long as it's got the positive exponents. All right, going on to the last one, grade 11s. Example G. We've got 3y plus 2x squared equals xy in a square root. Okay, so I don't like working with surds, so I'm just going to convert that. So we get 3y plus 2x squared is equal to xy to the power of a half. Okay, so let's start differentiating. So that's going to become 3 dy dx plus 4x equals. Now here we've got to do the chain rule. Okay, so multiply that with the front and we get a half xy minus 1 from that, and we get minus a half. Now we need to differentiate the inside. Okay, so we've got a product here. So it's going to be the derivative of the first, leave the second, plus leave the first, differentiate the second. All right, and there's the derivative of that. So let's take dy dx to this side, everything to that side. So we've got 3 dy dx. Right, guys, I'm just going to miss a few steps here. If I multiply that in there, I'm not getting a dy dx. If I multiply that in there, I do get a dy dx, and I'm going to take it to the other side. So we get minus a half, and it is going to be xy to the minus a half dy dx is equal to. Now multiply that in there, and we get a half y xy to the minus a half, and then if you take that to the other side, we get minus 4x. Okay, take out the dy dx as common, and we're left with 3 minus a half x xy to the minus a half is equal to half y xy to the minus a half minus 4x. Divide 3 by this bracket. Okay, and we're almost there. I just need to change these things to positive exponents. So we get y over 2xy to the half minus 4x all over 3 minus x over 2xy to the half. Okay, guys, and that is it. All right, I'll do part 2 now with the rest of the questions.